Hello students, this is Professor Chalai, and in this video we're going to go over some of the things that you need to know for the freezing point and molar mass lab. So let's get started. First I want to go over a little bit of a recap on freezing point depression. According to freezing point depression, it says the freezing point of some solvent is lowered if we add some solute to that solvent, making a solution. And the equation for that is exactly what I'm writing here. The change in the freezing point is equal to I, which is the Van 't Hoff factor, lowercase m, that's the molality, and some freezing point depression constant Kf. As a reminder, the molality is the moles of solute over the kilograms of solvent. So what we're going to explore in this lab is exactly what's the freezing point of some solvent and how does that freezing point change when we add a solute to it, making a solution, and then can we calculate the molar mass of that solute from exactly how much the freezing point gets lowered. Okay, so instead of using a solvent like water though, we want to use a different kind of solvent that freezes at a temperature above room temperature. And the reason for that is it's easier to heat something up and let it cool than it is to, for example, lower the temperature below room temperature. So the solvent that we're going to use is naphthalene, right? And the way we're going to do this is we're going to grab a test tube of naphthalene, right? And we're going to heat it up in a water bath to melt it. So that water bath is going to be on a hot plate. Right, so we're going to put it in the water bath, heat it up to melt this naphthalene. And we're going to have to make sure that we have a stirring rod in there as well as our temperature probe, right? So this would measure a temperature. And so we're going to heat this up to melt the naphthalene, and then we're going to allow it to cool. And so if we think about our heating curve, if this is our temperature, right, and this is time here as it cools over time, we're going to have a liquid that slowly cools. And then when that liquid hits a particular point, the freezing point, right, it's going to turn from a liquid into a solid, and then when everything is solidified, it's going to cool again. And from that little point right there, we know that's going to be the freezing point of this liquid. Right? Then we're going to add the solute to this, right? And we're going to use a solute that's sulfur. About 1 gram of solute to the naphthalene, which would be about 15 grams. This will be our solvent. And then we're going to repeat this exercise, and in theory, right, the solution with the solute added in there should cool at a slightly lower temperature because of freezing point depression. So there's going to be some drop in temperature here. That's our change in freezing point, that change in temperature. So what we can then do with that is figure out exactly what's the concentration from that freezing point, because we know that the change in freezing point is the Van 't Hoff factor times the molality times the freezing point depression constant. For naphthalene, this will be given to you, right? It's 6.9 degrees Celsius per molality, right? And because this is a covalent solute, the Van 't Hoff factor should just be 1. So if we know the freezing point depression, we can calculate the molality as the change in the freezing point divided by the freezing point depression constant, Kf. Okay, once we know the molality, we can actually calculate the molar mass of this, because we know that the molality is moles of solute over the kilograms of solvent. If we know the kilograms of solvent, and we should because you measured the mass of the solvent earlier, then you can figure out the moles of solute, right, just by taking the molality and times it by the kilograms of solvent. This will give you the moles of solute. The molar mass, if you remember, is mass of solute, or mass over moles. So we know the moles of solute right there, And we should also know the mass of solute because you would have measured it out earlier, and you would be able to figure out, oops, I draw the arrow to the wrong thing, there's a mass of solute. You should be able to figure out the molar mass of that solute. Okay, so let's go through just a quick practice problem, assuming that our solvent is not naphthalene, but water. And water has a Kf of 1.86 degrees Celsius per molality. And let's say in this particular experiment, we're dissolving glucose as a solute, glucose, right? And you dissolve, let's say, 1.00 grams of glucose in 15.00 grams of water, similar to the experiment. And we did this experiment, we find a freezing point of water, 0 degrees Celsius, and we dissolved our 1 gram of glucose in water, and we redid this experiment, and we now found that the water froze at negative 0.7 degrees Celsius, so we have a change in freezing point of 0.70 degrees Celsius, right? I would like you to use this information to calculate the molality of glucose. Okay, so to calculate the molality of glucose, we said is the change in the freezing point is the Van Til factor times the molality times Kf. The Van Til factor, again, this is a covalent molecule, should just be 1, so the molality is just the change in the freezing point divided by Kf, which in this example is 0.70 degrees Celsius, divided by the Kf for water is 1.86 degrees Celsius per molality, so the molality is 0.70 divided by 1.86. We should get a number like 0.37 m. Okay, with that, calculate now the number of moles of the solute. Okay, so if we have a molality of 0.37, that's 0.37 moles of solute over 1 kilogram of solvent. But we use 15 grams of solvent. So 15 grams is 0.01500 kilograms. We should get a moles that comes out to be, if my calculation is right, 0.37 times 0.015 gives me 0.0055 moles. Okay, so now that we have the moles of solute, we can figure out the molar mass. So the molar mass should be the mass of solute over the moles of solute, which in this case should be our 1.00 grams of solute that we use, and the number of moles here is 0.0055 moles, so we get a molar mass of 180 grams per mole, which if you look it up is the molar mass of glucose. Alright, I will see you all in labs.